problem, the first lens is convex, second lens is concave, and third one is going to be the mirror, which is plane mirror. The I1 is the first image found by the lens, first lens. This will be the object for the second lens, and I2 is the second image found by the concave lens, and it will be the object for the plane mirror, and so on it will become actually. Okay, we have to first locate where is the I1, and then we should decide what is the nature of O2, and then we have to decide I2 and so on. Okay, and whatever the lens that they given here, whether convex or concave, thin lens formula is applicable here. 1 by V minus 1 by U equals to 1 by F. This formula we can use for both the lenses. Let us use for first image distance. So this is V1 and this is U1. This is going to be F1. Now 1 by V1 is going to be minus 1 by U1. Object distance for the convex lens is 60 centimeters, but as I have told you clearly that sign convention is very important. The light ray is coming from left to right, so right side distance of the convex lens, say this is A lens, is positive, left side is negative. Anyway, this is a real object, so real object distance is always negative, I told you already. So minus 60 equals to 1 by focal length of the convex lens is how much? They have mentioned clearly 30 centimeters. So solving this, 1 by V1 is equals to 1 by 30 minus 1 by 60. It will be again 1 by 60. There is no doubt in that. So you found that V1 is plus 60. Okay. The meaning of that positive image distance, I told you clearly. If in case of refraction, positive image distance stands for real image. Reflection, it is a virtual image. Okay. In case of refraction, negative image distance stands for virtual image. Reflection, it is real image. Okay. So you should remember the statements like this. So it is at 60 centimeters from the convex lens. But in front of the convex lens, there is a concave lens at a distance of just 20 centimeters. Then the diagram, if you can imagine the situation, the ray diagram will be this way. This is a convex lens, principal axis, concave lens, right? Now the light ray will come. Let us change the color. Light ray will come, and according to the solution that we have provided, it has to converge at 60 centimeters. 60 centimeters. Say this point. That means it will be going like this, and it has to go and meet this position. Similarly, this is one more ray, and of course this will go undeviated, and it will be converged. So at this point, actually this is I1, okay, but because of this concave lens, which is at 20 centimeters, these rays will not converge over here. Property of the concave lens is to diverge the beam, so the point of convergence will be in front of somewhere here. Okay, that we will have to prove. So how to decide the object distance for the concave lens? This image 1 will be the object for the concave lens. Okay, so object distance is going to be from the concave lens to the first image. The distance is very clear. Total is 60. This gap is 20. So this is going to be 40 centimeters. Clear? So object distance for the concave lens is going to be 40 centimeters. And from the definition of real object and virtual object, we can say this image is actually virtual image. It will behave as a virtual object. Virtual object distance is positive, so only it is positive. Otherwise, you can use the sign convention also. Light rays are going from left to right of this lens B. So left side distances of lens will be negative, right side distances of lens will be positive. So in that way also U2 is going to be plus 40 centimeters. Then 1 by V2 minus 1 by U2 equals to 1 by F2. This equation we can substitute the values and we can find 1 by V2 equals to 1 by F2. Focal length of the concave lens focal length is 120 centimeters. So it is 1 by minus 120 you should take because it is concave, and this u2 will come as positive here, 1 by 60, sorry 1 by 40. Solving this, you will get 1 by v2 value. It is going to be minus 40 plus 120, 80 divided by 40 into 120. It is going to be 2, so it is going to be 120. And what you can find that v2 is plus 60 centimeters. The meaning of this plus, again I told you already, plus stands for image distance for positive means real image. That means from here the light rays will come and meet over here. Sorry. From here the rays will come and meet over here. The diagram, this should have been straight. This they will meet. Actually they have to converge over here, but they will converge over here, right, because of the concave lens. Now let us go to the diagram. Between concave lens and plane mirror, the gap is, as we can see, if this is 20 and the total is 70, this is 50, right? But in the problem what we have showed, from the concave lens at 60 centimeters it will converge. That means before they fall, before they converge, they have to incident on the plane mirror. So if I draw the diagram, this is a plane mirror, sorry, let this be the plane mirror. Yeah, the reference line is this. They will go like this and they have to converge, but they will deviate from the actual path. This is how they have to go, but they will deviate from the actual path. They have to meet here, but they will deviate and go, so that they have to meet over here, right? This gap is 20, this gap is 50, but from this point to the point where they are supposed to converge is 60. Then the gap between these, like this gap, is going to be 10 centimeters. Right? Now this is actually second image, which is virtual image again. This image behaves as object for the plane mirror. This is a plane mirror, right? Okay, this is the object distance, third object. Now it's very clear for us. The third image is here, sorry, second image is here, then third image will be reflecting like this. Here it will form. You know very well, for a plane mirror, if real object is there, then image will be virtual. If virtual object is there, then image will be real. Okay, in that way also you can find, but we can use the lens equation, mirror equation, 1 by v plus 1 by u equals to 1 by f, where f is for plane mirror, 1 by f is 0, because for plane mirror focal length is infinity. Okay, so 1 by v plus 1 by u is this u3, that is how much, 10 centimeters, should be equals to 0. Then we can say v equals to minus 10 centimeters. And I told you already, in case of reflection, negative image distance stands for real image, positive image distance stands for virtual image. So in front of the plane mirror at a distance of 10 centimeters, the real image is formed. Then let us see the options, right? First option, 60 centimeters from the convex lens. Yes, obviously, because if you see the diagram, from the convex lens to the plane mirror, the gap is 70. From the concave lens to the plane mirror, the gap is 50. Okay, and this gap is 10. Right? So obviously the convex lens to the real image, the distance is going to be 60 centimeters. So option A will be correct option. Let us see the second option also. From concave lens 60 centimeters they say, okay, it is wrong. And next 70 centimeters from the convex lens, that is also wrong, okay. And option D 70 centimeters from the concave lens, that is also wrong. So first option is going to be correct option. Remember, in case of refraction, the real image distance is positive, virtual image distance is negative. In case of reflection, the real image distance is negative, virtual image distance is positive, okay. Don't get confused.